4 times 10 to the power of -2 as a decimal.
Yeah, I can take that one unless you want it. It's kind of an algebra.
Go for it.
So 4 times 10 to the -2, we want to write that as a decimal.
Scientific notation.
Yeah, and so it's really important to know your properties of exponents here. So what we know is when I raise any number to a negative power, it's kind of like we're flipping it. So we could actually rewrite this as 4 times 1 over 10 to the second.
That is so confusing to students.
It really
I
is.
think.
And actually, I'm glad you said that because I think a lot of students ask, like, why is that? And I think you had a really good explanation for that before. So
I've definitely seen a couple explanations. The thing that at least makes the most sense to me is, so a positive exponent is like repeated multiplication.
right.
So a negative exponent is like repeated division.
Yeah.
So 1 divided by 10, 2 times.
So
Maybe one way to think of it.
yeah, and if we just write it out, it kind of makes it a little bit more clear, right? So if I say, like, I got 10 to the power of 1, well, that's just 10, right? Because we're just saying 10.
One of them.
Yeah. But like Becca was saying, if we have 10 to the second power, well, that's 10 times 10. And if we have 10 to the third power, that is 10 times 10 times 10. We could do this forever, but, well, we can't because the show will be ending in like an hour or so.
Time is a constraint.
But let me move this stuff out of the way really quick so we can see how this looks. So this equals 100. 10 times 10, sorry, that's 1,000.
Yep.
Thanks. This is 100, and then this 10 is obviously just 10. So like Becca was saying, if we think about this, we're really like multiplying by 10, multiplying by 10. If we kept going, oh, that's a weird multiplication. If we kept going, we would be eventually, we just keep multiplying by 10, like adding another 0 at the end every time. But if we go the opposite direction to get back down, well, 1,000 divided by 10, if that makes sense, is going to bring us to 100. And then 100 divided by 10 is going to bring us to 10. And the important thing in math, right, is we always have these like repeated patterns and rules that will keep on working over and over again. So we have to be able to keep on applying that. So if I went down to 10 to the power of 0, and this is one that throws everybody off, right? We're really taking this and we're dividing it by 10, and we're going to get 10 divided by 10, which is 1. And if we keep going, what did I write 10?
Yep.
I like wrote it and looked at it and said 1. I don't know.
Thinking and writing and
been a long
talking
week,
at the
yeah.
same time. I know.
So if I go 10 to the power of -1, continuing that, like, oh, let's see, now I forgot a 1 actually. Where'd it go? If we keep going in that pattern, we're going to divide by 10, right? That's what we're doing every single time. And this keeps on applying. 10 to the -2nd, well, we would divide this by 10, which would give us 1 to the 100th power. So that pattern is, I think, really helpful to see because it helps you understand what is happening with this pattern. We say 4 times 10 to the -2nd. So the way that we do that, I'm going to move this all over here. When we say 4 times 10 to the -2nd as a decimal, well, we're going to say 4 times, and if you look here, it's 1 over 100. Well, we could think of this as 1 over 10 squared, which becomes 4 times 1 over 100, which you could rewrite 2 ways. You could plug in your calculator, or you could remember anytime I divide something by 100, I'm really, if you remember this shortcut, I'm going to take the number 1, and I'm going to look at where the decimal place is and move it 2 places to the left, and then fill in the gap with a 0. So this becomes, 4 equals over there. I am just off today.
Falling apart.
Yeah. 4 times 0.01, and then that becomes 0.04 as a decimal. Right? So, you want to add something?
I do.
Yeah. So that's, again, like seeing that pattern, understanding how to manipulate exponents will get you that decimal.
I'm going to add something to that too. If you think about, so you've probably heard elementary school teachers, and sometimes it drives me crazy because they say it wrong, but when you multiply anything by 10, just add a 0.
Right.
It's like not really what's happening. So frustrating, of course, because think about this example, 4.0 times 10. Oh, I'm just going to add a 0 on that.
Oh,
well,
yeah.
That doesn't really work.
Right.
So just adding a 0, kind of incorrect way to say it, but a lot of times I hear students repeat that to me, like, oh, my teacher just said to add a 0. What's really happening when you're multiplying by 10 is you are moving your decimal point, your place value over one point is what's really happening. If you're multiplying by 100, you're moving your decimal point over 2. And that's why those zeros are being added. Now, the same kind of goes if you are dividing by 10 or dividing by 100, except you're moving your decimal point in the other direction. So 4 divided by 10 would be 0.4. Or in other words, 4 times 10 to the negative 1. Same thing, would be 0.4, because we said those negative powers are like dividing, right? So you see something like this, 4 times 10 to the negative 2. Well, that means I'm dividing by 100. So what that means is I'm going to take my decimal point and move it over 2 spots as well. So that's maybe another way to think about it. I don't know. Just
And I like the logic. If you're multiplying by 10, you move to the right. And in math, like division undoes, or kind of think of it as like the opposite of multiplication. So you should do the opposite with the decimal place.
right.
Yeah.
So there's a couple food for thought, I guess, for
Yeah.
you, since we're on food today. All right.